Math 114, 5.2, multiplying polynomials. Objective 1, use the product rule for exponents. The product rule of exponents states that if we have b to the power of n and b to the power of n, and they're multiplying, then the exponents will be adding. B is known as the base. So if they have the same base, then the exponents will be adding. Example of this, if we have x squared times x cubed, then this becomes x2 plus 3, which equals x to the 5th power. And this is like the one we did a minute ago. So this is x cubed times x to the 5th. We have the same base, so that means the exponents will add with each other. So we have this one, which only involves numbers, is a constant, but the same rules apply. We have 2 cubed times 2 squared. That means that the bases are the same, which is a 2, and we have 3 plus 2. That makes this 2 to the 5th. So that's going to give me 2 times 2 is 4, times 2 is 8, times 2 is 16. This is 32. So here we have y. They have the same base. So I have y to the 4th times y cubed times y squared, which equals y4 plus 3 plus 2, which equals y to the 9th. Power rule for exponents. When we have a base to the power of a power, that means that the base will multiply. The exponents will be multiplying. So let's see an example of this. So we have a base, which is x, which is to the 2nd power, which the 2nd power is to the 5th power. That means that this becomes x to the power of 2 times 5, which is x to the 10th. This is 3 to the power of 4 to the power of 2. This becomes 3, 4 times 2, which equals 3 times 8. And 3 to the power of 8, just 8, not 88, is 6,561. So this we have. This becomes to a power of 21, we have that huge thing. Okay? This rule is products to powers rule. It's more like the distribution property. In a way, we have a to the b of n. That means that both a is to the power of n times b to the power of n. So this means that this becomes 2 to the power of 4 times x to the power of 4. And 2 to the power of 4 is 16x to the 4th. This one we have negative 4. Y to the power of 2 to the power of 3. That means we have negative 4 to the power of 3 times y to the power of 2. This becomes negative 64. Y2 times 3. So then we have negative 64 y to the power of 6. Remember, this is maintained its negative because we have negative 4 times negative 4 times negative 4. So a negative times a negative is going to give me positive 16 times negative 4, which is negative 64. Multiply monomials. To multiply monomials with the same variable base, multiply the coefficients and then multiply the variables. Use the product rule for exponents to multiply the variable, keep the variable, and add the exponents. Okay, so this is telling me to multiply. So we have 3 times 5 times x squared times x to the 7th. 3 times 5 is 15. We have the same base. That means the exponents will add. So we have 15x to the 9th. 15x to the 9th. Same thing here. So this becomes negative 5 times 4, x to the 4 times x to the 5th. Negative 5 times 4 is negative 20. We have the same base. That means the exponents will be adding. So I have negative 20x to the 9th. Multiply a monomial and a polynomial. To multiply a monomial and a polynomial that is not a monomial, use the distributive property to multiply each term of the polynomial by the monomial. Meaning I have to distribute. So I have 6x cubed times 3x cubed to the 5th minus, because that was there, 6x cubed times 5x squared plus 6x cubed times 7. Now, like we did the previous problems, this becomes 6 times 3 x cubed x to the 5th minus 6 times 5 x cubed times x squared plus 6 times 7 times x cubed. 6 times 3 is 18. Same base, that means they're going to be adding, so it's going to be 3 plus 5. 30. Again, same base, means the exponents I'm going to be adding, plus 42. And that one stays. So I have 18 x to the 8th minus 30 x to the 5th plus 42 x cubed. Multiply polynomials when neither is a monomial. Okay. So to multiply two polynomials, multiply each of one of the polynomials by each term of the other polynomial, then combine like terms. So this is telling me, I know you know it by FOIL, but let's ignore that. Let's just use the distributive property. So this becomes this. I'm going to distribute like so. Okay. So I have 5x times 2x minus 7 times, or 5x times 7 plus 3 times 2x minus 3 times 7. So that's going to become 10x squared minus 35x plus 6x minus 21. Do we have like terms? Yes, we do. These two right there. So this becomes 10x squared minus 29x minus